I found some time to work on the Delta printer over the weekend and a little bit more today. And the first thing I did is I downloaded a version of Marlin that was given to me by commenter John M. Thank you for that, John. And that's running right now. And he kind of sold this firmware as like a bug check. It seems to me to mostly just be doing the same thing that my build was doing. He just has more points in the grid. So it spits out a lot of calibration points. But I'm having the same issue. So I still am off on this far edge of the board over here, whereas on this one I'm pretty close to being accurate, right on the board, as far as Z height goes after I run an auto calibration. So I'm really starting to think that the problem is not in firmware, and it's a physical problem. And so the first thing that I did is I checked the frame to make sure that it was all square and put together correctly. I mean, I put it together, but I just wanted to double check my work. And what I found was some gaps down here on the bottom. So let's take a closer look at that. We can see that this one's nice and gap free. Can't fit my fingernail between the plastic and the 2020 extrusions. We can pan over here though and look at this one. And there's a little bit of a gap here. In the front, it's harder for me to slide my fingernail in, but I can get it in. And towards the back, the gap actually widens quite a bit. So if I hold my my caliper here, geez, that could be almost a millimeter. So quite a bit towards the back. Now, this imprecision is probably coming from these injection molded parts. Now these aren't nylon, these are actually just ABS. So they could be better, but you know, they got to make these printers inexpensive. That's why we only paid $170 for these. Up here we can see that I had no problems making it so that the parts were absolutely flush. I can show you all of the corners here at the top, but it's really not necessary. They're all perfectly tight. So unlike the bottom, I had no problems just pushing by hand and getting that to be sucked up without any gap. But down below, there was just, you know, it couldn't do it with my bare hands. So we're gonna fix that right now. And this is how we're gonna do that. So I have here two pretty massive wood clamps, and we're gonna clamp the frame, we're gonna loosen the bolts, and we're gonna clamp the frame and make sure that everything is nice and tight. A quick note, what I'm trying to do with all these videos, I have a lot of tools at my disposal, but I'm trying to make these projects doable by anyone with a minimal amount of tools. So there's another way that you can accomplish what I'm about to do, and this is that way. So pretend that this is just a big rubber band, but let's pretend that this was a rope. So what you would want to do is get that rope to where it's wrapped all the way around your frame. So you would get underneath the frame and you would loosen, or maybe you'd take the bed off here and you would loosen all those screws that hold the all the 2020 extrusions there, so that they're all loose and they're able to move. Then with your rope not being tied too tight, you would want it to be a little bit loose. You would use a piece of metal bar if you had it, maybe like a wrench. You could just use like an open-end wrench for this purpose, but it needs to be something strong. A thick dowel might work. Anyway, you'd stick it inside of the rope and you'd start twisting. So you get it spun like that, and as you spin it, what's going to happen is that rope's going to get tighter and tighter, and it's going to clamp it down tighter and tighter. So you get it to a point, you could probably, you know, stick it back into itself, do something like that. Hopefully, you see that how that pen just spun? You want to avoid that. But with that held tight and somehow taped down so that it's not going to go anywhere, you would get in there and you'd tighten all those bolts. And that's how you could also do what I'm about to do with the clamps. Okay, so you can see that I'm pretty sure my frame is all straight now and everything looks good. But after doing that, I still have the same problem. It did get a little tiny bit better though, I gotta say. Changing my frame definitely improved things slightly. So where could the problem be coming from if it's not in the frame? Well, I decided to revisit the rod length issue. And what I did is I took a rod off and I measured the bolts, the actual threaded portion of the bolt that goes through the eyelet. And that came out to be 2.9. Then I measured the hole in the eyelet itself, and that came out to be 3.1 millimeters. So we have a difference of 0.2 millimeters. Well, what I found out is that an aluminum can is exactly 0.1 millimeters thick. So if you wrap it around the bolt, you will get 0.1 millimeters on one side, 0.1 millimeters on the other side. There's 0.2 millimeters, which should make the bolt and eyelet perfectly seated into one another. So there should be almost no play. So I went and I did that with one single rod just to test it. And after I'd done that with a single rod, I tested the end effector. I grabbed it just like I'm doing and wiggled it. Now let's take a closer look at that. So here are the two eyelets at the very front of the machine. And if I grab the end effector off the top of the screen here, up out of the shot, but I'm going to grab it and wiggle it, and we're going to see the play. You see the play on that left eyelet, but you see we're not getting any play here in the right eyelet. We're not getting the same amount of movement. So what happened is I tested these eyelets for play, but I only tested like 2 or 3 of them. And I must have tested 2 or 3 that were like this one here that didn't have any play in them. So some of them have a lot of play and some of them have no play. And that's very problematic. And here's why. If we look at this being the eyelet with the 1/10 of a millimeter plus and 1/10 of a millimeter minus play, okay? And that sits darn close to the center line, which is where the nozzle sits, right? Then we look at where the probe sits, and it's about twice the distance from the center. So any play in here gets doubled by the time it gets to the probe. So that means at the probe, just because of this wiggle, we have 2/10 of a millimeter plus and 2/10 of a millimeter minus, which makes an overall variance of 0.4 millimeters. That's just stationary right here as it sits as I wiggle. When I slide the end effector all the way to the end of that end of the board, what ends up happening is you can actually dive this end down and pull that end up also by 0.4, and then the opposite is over here. So that doubles our 0.4 to being a 0.8, which is almost an entire millimeter of variance. And that's strictly because of this tilt that can happen in the because of the wiggle, the very bad tolerances in these eyelets. So it's absolutely critical that you get those lengths correct and that they are all matching so that you have the same measurement at that end of the board and at that end of the board. And it's absolutely critical that you do not have any wiggle, any play. If we look at the original review video that I made on this printer, we can see that I predicted this problem. I would prefer zero lash magnetic joints and carbon rods. Okay, well, why didn't I buy these 3 months ago? Let's buy them now. Go to eBay here. We've got diagonal push rod, L200 magnetic ball joint, blah, 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 blah. Currently going for $12.99 with $2 in shipping. So $15, and you've got yourself some zero lash carbon magnetic ball joint arms. Very cool. So I ordered this kit and it should be arriving, I don't know, in like 2 weeks. So I'll have to update you guys once I've fixed my printer with this kit. But in the meantime, I thought I'd tackle another problem with the printer, and that is that the board is a little bit underpowered. It does the job, but I've always kind of wanted to upgrade to a smoothie board or a Duet. Now the Duet is the 32-bit ARM processor. I think it's the same processor as what's on the smoothie board, and people seem to like this board better. It's a little bit more new. So let's go look at ordering one. Well, the Wi-Fi is the one that I want, and it's 120 pounds, which is like $150 American, I think. So yeah, that's kind of expensive. But I thought I'd look around this site some more, and hey, what's this? And this is a very, very new product, you guys. This is like 2 months old, I think, not even. And it's super interesting. So obviously we have a problem with effector end tilt because our sensor is way off to the side of our nozzle. Now, who cares if the effector tilts a little bit? When our nozzle's in the dead center, it doesn't really move, okay? So if our sensor was attached to our nozzle, we wouldn't have a problem. But then you do have other problems in that your nozzle is now moving, right? Because it's got to have a switch attached to it or something like that. So it gets pretty convoluted. Well, this is a genius solution. Seriously, whoever thought of this? It's like staring us all in the face, and yet whoever thought of this is the one who came up with it. It's great. So printed right into this PCB is a strain gauge. Now that's the same type of a gauge that's used in digital scales, and if you're a cyclist, that's what power meters use. And it basically just measures deflection in the PCB. And the smallest, we're talking microns, the smallest amount of deflection the strain gauge can measure. It's really, really sensitive. So without having any moving parts, without changing the where your print nozzle sits, it's actually measuring the board height, or I'm sorry, the bed height using the extruder tip. So smart, you guys, so smart. This is the future for sure. Now, that's pretty expensive for a PCB. I mean, it's just a strain gauge printing it into a PCB. They did get a custom E3D hot end. Oh, there it is. They had to get those threads custom milled by E3D, but yeah, I mean, I guess $45 is the price you pay for being on the cutting edge, because this is like a 2-month-old product. Now, eventually, of course, China will get their hands on this, and we'll see these for like $5 or $10, which will be a good day. This is for sure the future. Let's get away from all these switches everywhere and just simplify and also have flawless operation. And it won't matter if our arms have a little tiny bit of play in them. This will still be plenty accurate. But you can see with this kit, they also sell these zero lash magnetic ball end rods. And hey, those look 3D printed. So I think this is how I'm gonna make my rod ends as well. I'm gonna 3D print those, so yeah. Speaking of new things, did you guys see the Prusa i3 Mark III? This is so cool. Prusa, I mean, go watch this video if you haven't seen it. The thing that I'm absolutely most impressed by is this bed. So it's spring steel, and then they've powder coated it with, you know, like a really good print surface that doesn't stick, but because it's spring steel, you can just bend the bed and it'll spring right back into shape. And because you bend the bed, the part doesn't have to bend and the two pop apart from each other. So you'll never put a knife on this. You'll just pop the part right off. Genius. There's so many great advances being made in 3D printing. It's so cool. Oh, and by the way, I'm a mother flippin' genius. Yeah, go watch the video, I'll link it in the description down below, where Joel, the 3D printing nerd, is interviewing Joseph Prusa about the changes to the Mark III and the Mark III. Prusa looks you right in the camera and he says, you know, how important it is that you get the sensor drift based on the temperature of the sensor itself, which is why they integrated a temperature thermistor into the sensor itself. So yeah, that's a great innovation and everything. And again, Prusa, awesome, awesome company. But go check out this video I made 5 months ago about the temperature drift in inductive sensors. So I think I was the one who broke this story, who figured this out, my little scientific study that I did, that silly little video. Me with my little YouTube channel of like, what, 3,000 subscribers. So 5 months is a pretty short time span for a company to figure out a problem, work out a solution, and then go into production on that problem. So it is unlikely that it was my video that showed that, but at the same time, I figured it out by myself. I did that. Something that Prusa, with all of his engineers that he has on staff, also figured out. So yeah. So that's where the project stands, and we're just waiting on parts now. And as soon as I have those ball end arms received in the mail, then I will get the printer working. I'm predicting that it should be pretty smooth sailing at that point. And after I have it working, I will make the tutorial video and upload that to YouTube so that all of you can do the same thing. Get your printers working with auto mesh bed leveling. So yeah. Hey, what do you guys think of that, the new Prusa printer? I'm sure most of you have probably already seen that, but so cool, right? I mean, I'm a total fanboy for Prusa, and I don't even own one. They're progressing the hobby like nobody else around. I mean, go watch that video. That bed thing, that's just the thing that I like the most about it, but there are like so many innovations in this latest version, and they've just got more in store. If you watch the video, they'll hint at that too. I think the Prusa printer should integrate a strain gauge sensors for the auto leveling feature. That's totally something Prusa should adopt. So yeah, there's just so much going on with 3D printers. This hobby is ever changing and it's just so much fun. So stay tuned. I will try to cover more of it as much as I can. And leave a good comment and hit all the good buttons, and I will see you next time.